When being stuck for a long time in traffic, older adults, like many other age groups, can be affected in many different ways. However, they may experience more critical effects on their health. Previous studies showed that some of the health-related problems that occur more frequently are stress, eye strain, headache, and pain in different parts of the body, for example arms, hands, legs, and back. Due to traffic congestion in large cities, some older adults might prefer not to leave home in order to avoid these problems. The last national census, carried out in 2005, reports that the population of Mexico was 103 million people, where 8% were older adults. It is estimated that by 2050, 26.6% of the Mexican population will be in that group. Due to the decrease in the birth rate, the number of older adults continues to rise in relation to the rest of the population of Mexico. The increasing pervasiveness of mobile technologies enabled with geographical positioning systems makes possible a scenario where traffic congestions will not just be avoided, but even trip efficiency being optimized by the aggregation of information from different users in a context-aware crowdsourcing model. The implementation of such solutions would be particularly beneficial for older people if the interfaces, interactive models, and services are designed to cover their needs. In order to design for a specific group, it is important to understand their needs. Because of this, we use user-centered design or UCD techniques to understand the need of older adults and to establish the criteria for both design and functionality. Before we started working on the implementation proposal, we had to get information about the problem and how senior citizens feel about adopting new technology to solve them. Our research took place in 5 stages: contextual interviews, design, prototyping, usability tests, and proposal redesign. In the contextual interviews, we interviewed 6 seniors between 60 and 75 years old, 4 men and 2 women that drive regularly in Mexico City. The following scenario illustrates the use of SAMM. This is Felix. He is 68 years old and lives in a big city. Felix would like to visit his grandchildren more often, but traffic makes it very hard. For this reason, Felix has just purchased a SAMM device. This allows him to move around the city without getting stuck in a traffic jam. SAMM takes him through Main Street since it isn't too busy at that time of day. She is Mary. She is 63 years old and lives in the same city as Felix, 2 blocks from Main Street. She uses the SAMM device to get quickly to the grocery store. Soon after taking Main Street, an accident happens and trouble starts. Mary reports the accident using SAMM's interface. The report is sent to the web service. This processes the report and warns other users with similar routes. Then, the service finds a new route and sends it to the user. Even though Mary doesn't know Felix, her report saves him lots of time, allowing him to reach his destination quickly. In the last few years, we have witnessed the great things technology can do for us, and how computers can change our lives. Now, we are definitely seeing the beginning of a ubiquitous world, one where computers merge with simple objects, and information is everywhere. One where technology is mobile, pervasive, and used by all types of users and age groups. The visions of pervasive computing such as this will bring great benefits. With this in mind, and in order to take SAMM a step forward, we now briefly discuss a number of new functions and technologies with the potential to complement its original design.